Hello everyone and welcome to the RoboCon 2021 remote event. My name is Joshua Grosby and I am a Principal QA Engineer at SecureWorks. I am presenting this RoboCon workshop called Getting Started with the Robotframework-AppiumLibrary. By the way, here's my LinkedIn profile and my Twitter profile in case you want to reach out. Before we begin, I want to thank the following people and groups: Pekka Clark, Ed, and Serhat Bolsu. Thank you, Serhat, for creating a great Appium library for the Robot Framework community. FYI to Windows users, the Robot Framework Appium Library workshop I will be presenting uses a lot of bash scripting, so here are some options that might help you. I've not tested them myself. There's the Windows subsystem for Linux, Git for Windows, and Cygwin. Here's an introduction and workshop outline. This is going to be a hands-on workshop. I'm going to be combining Robot Framework Appium Library examples with various tools. I'll be jumping back and forth between slides and running the examples from a terminal. From a high level, there's two parts. Part one is technical requirements summary, Appium installation advice, some mobile device, emulator, and simulator setup guidance. I'm also going to be demonstrating app automation workflows for iOS and Android, and I'm going to be also showing some ADV shell examples. I'll also be demonstrating some browser automation for Safari on iOS and Chrome on Android. In part two, I will do a walkthrough of Appium Desktop, and I will also show some Charles proxy examples combined with Robot Framework Appium Library. I'll also be demonstrating an example of PA-Bot running iOS and Android simultaneously, combined with GraphWalker, which is a model-based test tool. And at the same time, while both of those tests are running, I'll show an example of an Android emulator CPU monitoring running in parallel with those examples. So in this slide, these are the technical requirements. Please take a look. Pause the video. I recommend you start installing them now. Also, please download the code from Git. Use git clone, or you can download the zip from the GitHub webpage I provided. So here's some Appium installation advice. Please make sure you've reviewed all of the items in the technical requirements summary slides. The basic requirements for this workshop is basically Node.js version 14, Python 3, and Java 11. I mention these versions because these are the versions I've used to build out these workshop examples. Also, I recommend using NVM for your Node.js installation. I've tried installing with Homebrew, and the Big Sur update on my Mac broke my Homebrew. As you can see, this error in the screenshot prevented me from installing Node.js after Big Sur update. When you have Node.js installed, you can move on ahead to getting started instructions found in the Appium website. You should be able to run the Appium server install command here, and also the Appium doctor command. After you've installed Appium Doctor from a Windows operating system, you should see this output from your command line. From a Linux operating system, Appium Doctor should give you this output. Now, when you start running Appium Doctor, you should notice that if there's any red X's displayed, you want to follow the instructions for installing, like for example, Carthage here. Just work through all of the red X's, follow the instructions until you get green check marks from Appium Doctor. This is a Mac OS example. Let me show a quick example from my machine. This is a verification showing that the necessary dependencies have been properly installed on my Mac. You want to focus on the necessary dependencies. You can also do the optional dependencies if you like, but these dependencies up here are what's important for the workshop that I'm going to present to you. Moving on. So setting up your Android emulator, you start Android Studio, click on the configure button, which is right there, and click on AVD Manager. So let's try that. Once you open AVD Manager, you just click on Create Virtual Device. There's a lot of options here, different categories. You have phones, TVs, wearables, tablets, automotive. So we're going to hit Next. Choose the system image. Hit Next. At this point, you could hit Finish. I'm going to hit Cancel because I've already got that device there. It's a very straightforward process with Android Virtual Device Manager. Next slide. Now, once you've set up your Android emulator, you should go into the root of the workshop repo. You want to go into this particular shell script here, this bash script I should say, and open it up in an editor. You want to change the following in this screenshot here in two places in the bash script to match the device that you set up earlier. Now, you don't have to do that. You can just follow the same example that I've already set up in there. I'm going to be doing workshop demonstrations with the Nexus 5. You can just set up the same device on your machine. When you install Xcode, you're already automatically installing simulators. So after you've installed it, just run this command. And you should see all of the devices, or simulators I should say, that you have installed on your machine. The one that we're interested in, if you want to be consistent with the workshop examples that I am going to be demonstrating, we want to make sure that iPad Pro 12.9-inch 4th generation shows up in Sim Control List. Now, you can also set up Xcode to automatically check for iOS updates by going into the preferences. So let's do that real quick. Go up here, click on Preferences, go to Components, and this is where you will download your simulator if you need to download a different version. This is where you can enable the check for simulator updates automatically as well. And if you want a specific version, you could just click on it, click on Check and Install Now. I'm not going to do that because that takes time, and I'm just going to move forward right now. The next slide. Okay, that concludes the installation portion of part 1. I'm going to move on to the examples of part 1. Okay, so before you run any examples, you need to run these specific commands first from your terminal or command line. Now, the test teardowns are going to clean up Appium instances that are running before, any emulators that are running before as well. The test setup is going to set up Appium without proxying, so it's Appium with no proxy. There's also a setup for Appium with proxy, for Charles proxy setup. That's for later on in the upcoming slides. After a successful test setup, you should see the emulator come up on your screen. This is the Nexus 5 that I've set up. Okay. Now we can move on to the actual first example here, which is an iOS test run. This will automate installing Wikipedia app on an iPad simulator. This particular test turns the iPad simulator into landscape mode, then switches it back to portrait mode. The test is just performing some simple searches on the Wikipedia app. It's going to search for cat, and it's going to search for dog. Okay, that's the example. Moving on. Right. Now here's an Android example. Also installing the Wikipedia app and performing some searches. And also does the portrait landscape switching test. Okay, now next is the ADB shell commands and the demonstrations of how we're going to use that for testing. This specific example here is going to show the status of a specific Android app process that is active. Let's run that. The active process that it's going to check is the calculator. As you can see, it posted the or displayed that the process ID, the name of the process, com.android.calculator2. It did a log to console. Okay, let's do another command. This command will show the file system contents for the current directory on the Android device. It will also log that to console. Takes a minute to run. Then from the console you could see the various directories in the current working directory. Okay. In this next example, we're going to look at specific package installed on the Android device. We're going to be filtering it with grep. And then we're going to log it to the console, just like the other examples. As you can see here, it again displayed that result in the console. The specific package we're looking at here is calculator 2. Our next example is detailed information on all installed packages. Now what this is showing from the in the console now is every installed package, including very detailed information about each one of them. Okay, and the next example is a list of featured information about the Android device. Basically a list of features that are, oops, typo. It's going to show a list of features that are installed on the device emulator. It's going to show it in the console using the log to console keyword. So here are the features: camera, fingerprint, location, GPS sensor, Wi-Fi, etc. This next example will show the current version of Android OS on the device. And there it is, displays 8.1 on the console. Okay. Some next examples. Now this command here will show the output of netstat, which is network statistics. So this is going to display TCP traffic going in and out of the device and display it in the console. There's all the TCP traffic. Okay. This next example will display the context list on the device. And there it is. This example will start a phone call and then end it. Just wait for this to clear out. This other example here will do a text message. We'll start a text message, actually. Won't actually send it. There it is. This command will collect system logs and place them into a file. It's logcat. It's a very useful command. This is the file it collected it to, my local machine. Alright. This final ADB shell command is bug report, which is combines the capabilities of logcat, some stack traces, and other helpful diagnostics. Let's run that. it's downloaded that into a zip file for me. Let's take a look at that real quick. That's the bug report zip file. That's it. That's the ADB shell commands. There are many more ADB shell commands that you could use. This is where I got the ideas for these ADB shell keywords. This is one of the best comprehensive lists I've found so far. There's a lot. There's hundreds of examples here, and I only used maybe 12 out of this list. There's so many more. So you should check them out and create your own keywords from the workshop examples. All right, moving on. So this part is browser automation for both iOS and Android. Okay. Opens up an app called NodeGoat. NodeGoat is a OWASP project. It's a vulnerable app. It's got a number of security issues. We're not doing pen testing right now. I'm just doing some simple browser automation examples. Next is the Android Chrome test. Let's move this to the side a little. Same test on the Nexus. It's going to NodeGoat, vulnerable app. Going to fill out the form. It's going to check the dashboard, and that's it. And that is the browser automation example. Okay, moving on. And that is the end of part 1. Now, moving on to part 2, Appium Desktop. So with Appium Desktop, there's a number of useful features. There's a convenient GUI for Appium Server, and also has easy access to capability sets, which you can store your settings for running your Appium sessions. Has connection options for cloud providers for mobile automation. Also has the very useful Appium Inspector, which also has a recording option that generates automation code. So let's take a look at that. First, let's run this. Seconds. You want to stop all instances of Appium before starting any Appium Desktop inspector or just starting it in general. Okay, now as you can see, I stopped the emulator through that command, and it also shut down the Appium servers. I set up 2 servers to handle parallel running devices. I only have 2 parallel running devices in the upcoming examples, as you'll see very soon. Okay. Now, when I start server here, the server is running without issues. Now, if you start the server from Appium Desktop while the other server is running, you'll get errors. Okay, now the inspector is starting. So here's the inspector view. These are the cloud providers. You can choose a whole bunch. And these are the capability sets I was talking about. There's quite a few that I've set up. If I want to edit it, it has this nice little JSON representation of my capability set for this iOS simulator. What I'd like to show is this capability set with Android. So I'm going to start it. I do not want testing bot. I want to have my own automatic server. So you want to set up automatic server. You don't want to set up any cloud providers. Just keep that in mind. It'll give you errors unless you want to use a cloud provider. So once I choose my capability set, I click Start Session. It takes a while to fire it up. Now, the reason why I did that is because I do not have an Android device turned on. The way to resolve that is to go back into Configure, go back into AVD Manager, and start it up. And that's the one I want to start up. Nexus 5. You can keep that in the background. Start a session, and now I have my inspector coming up. It's installing the Wikipedia app I was running earlier. Okay. Now, inspector can dive into the details of the UI elements of the installed app. Puts the app source in this nice tree view here. Do swipe by coordinates. You do tap by coordinates. Also, the recording option here. Let's demonstrate this. So I hit tap. Notice how it performs the action and also generates the this code here. There's choices for JUnit, Java, Python, Ruby, WebDriver IO. Can give you the individual line of code here for the action that I just performed. Now for Robot Framework, that would be click element in the search element, container element there. So you can show or hide the boilerplate. Gives you a nice little boilerplate to start with for Robot Framework. Very useful for starting brand new if you want to. But this is a very simple example. Also do send keys. Yep, be mindful of the elements being enabled or not. Apparently this was not enabled. Try again. Takes some trial and error to get a feel for it. and from here it recorded that as input text. Okay. That's nice, all copied to clipboard. It has a search for element feature too. And that's the inspector. Has code generation, has recording capabilities. You can find out where a specific element is by its coordinates. You can just if something is difficult to interact with a swipe or a tap by selecting the element, you could use a more analog approach with coordinates, which is pretty reliable, especially for when you need to deal with iOS simulators. Android tends to be a little more straightforward and reliable through the accessibility IDs, just by selecting the elements and then diving into the details of the UI, which will show up under App Source, and also in selected elements. It's a little difficult to read, but it's still very useful. Okay. So let's quit this session. Let's move on. And that is Appium Desktop. Lots of useful features there. Okay. Let's quit this. Close this out. I like to close out all of my devices, start fresh with a new setup. Doing a no proxy setup for this. Next slide. Actually, we need the proxy now because we're going to do Charles proxy. Okay, so Charles proxy is a very popular web debug proxy. It captures HTTP traffic from your local machine. You could use it for capturing HTTP traffic from connected devices. It's got a lot of features. It's a very, very, very good debugging proxy. It's very affordable too. It's unfortunately not free. A license key is required. There's a lot of built-in tools and features. The features that I'm going to focus on again is the HTTP traffic capturing and recording capability. Also, the headless automation features of Charles Proxy via the command line tools is my focus for this workshop. So the following commands will require the actual Charles Proxy setup, test setup. So I'm going to run these first. Let's clear this out. Oh. This is not what I wanted to do. It's okay. Let's just run the whole set of commands there. We'll run the setup. After the teardown, clean up for me, and then I'll do the setup with proxy enabled. Okay. Now, Charles Proxy is being started headlessly via a library that I wrote for Charles Proxy. And I have imported that into my Charles Proxy robot file. We'll take a look at the code in a minute. Ran the example on Android, and now it's running on the iPad. Don't be alarmed by these Java related console logs. It's expected from Charles Proxy. It's a bit verbose. Okay. So Charles Proxy keywords ran for both Android and iOS. Let's take a look at the code real quick so you can see how that works. Here's the Charles Proxy robot file for Android. This is the Charles Proxy library I wrote here. So I'm controlling Charles Proxy headlessly through this Python library. Start in headless mode, start a session recording, stop it, save it to a Charles Proxy session file. This is the raw file that I'm getting back. Now, the Android Charles Proxy Android example, I don't need that. They both work similarly, the iOS version and the Android version. So let's just take a look at how I'm doing that. I am getting a session file. I am converting it to a more readable format, and I am filtering it through JQ, which is a JSON filtering tool. And then I am checking the JSON output, filtering it for, does it contain here 200, does it contain 500 error codes, or I should say 200 status is desirable, of course, 504s, etc. So I'm converting it to filterable output. JQ is very fast filtering, and the Charles Proxy session file is often pretty big at times. I personally like JQ a lot because it does it very, very quickly. It's a very good filtering tool for JSON. And that's the Charles Proxy example. Again, the iOS example is identical. The great thing about Robot Framework is I can reuse a lot of things, and I can definitely expect it to behave the same way when I scale it out to other device types, etc. Okay. So moving on to the next part of the workshop. This next part is my personal favorite, using PABot, the parallel test runner, to basically drive two devices at the same time and also run a graph walker test on one device. On another device, the iPad, just run it in a loop. And in parallel, on the Android device, while it's running the graph walker test on the calculator app, run an ADB shell test to monitor the CPU usage. Okay, so let's run that example. Let's run that example. right, let's take a look at the devices up front. Okay. The Android device is being automated via a GraphWalker generated set of keywords, which is that is determined by a graph that I'll show after this test run. So not only is the path randomized, it's also based on the behavior defined in a graph. And I can change, the great thing about GraphWalker is I can change the graph rules, the way that edges and vertexes are traversed. I can change it to several different types of algorithms. Those are all covered in the GraphWalker documentation from their graphwalker.org, I believe. Yeah. I have the website. It's a GitHub website. There's also another website for it that has documentation and other examples. The PABot parallel test runner is an amazing tool, and it's going to be a permanent part of my toolkit for sure. I hope it becomes a favorite in yours as well, now that you can see what it can do. Running model-based testing side by side with just another type of testing. I'm just looping through the same exact test from earlier. It's very straightforward robot framework loop. I'll show the code after this. And I'll also walk through the code of the other examples as well. But most importantly, I'd like to show the CPU monitoring parallel test that's being done at the same time as this calculator test, which should have finished by now. Yep, that is done. But the iPad test is still going. Alright, should be concluding soon. Alright, so you can see from the console here the results of the CPU monitoring that was happening in parallel with the model-based test running on the Android. device. All right, it's done now. So I am capturing top data, and I am displaying it in the console. And I'm also checking that top data for high CPU usage. So let's take a look at the code real quick and walk through that specific example. Under the results, you can see the CPU usage logs here. I'm collecting the top data into this log file. I have this little checkpoint log file to capture instances of any kind of, to let me know how many instances of high memory usage there were, and there was none. Okay, let's look through the GraphWalker example real quick. Okay, this is the GraphWalker example. From the shell script that I provide, I am generating a CSV file here. And that is being triggered from the setup here. So this no proxy setup downloads the GraphWalker jar, then it runs GraphWalker, filters it through JQ to get the current element name, and I am putting that into a CSV file. So for this workshop, I've created a CSV file that ends at a specific time so that I can have all of the tests running at once and ending in close to the same amount of time. So I'd also like to point out that those tests, if they were run in serial, one after the other, would have taken 12 minutes. This parallel running test with model-based testing in an Android device and a looping iPad took 4 minutes, and also the CPU monitoring ADB shell test running in the background from within the Android device. Those 3 tests were running in parallel. That took only 4 minutes. 4 minutes, 43 seconds. So these are the 3 files. This is the top monitoring example. And this is where I am collecting the top data. I'm filtering for calculator 2. Building out the log file here. And I've set up checkpoint keyword, a checkpoint keyword here. This is my ADB shell command that I am using to collect the top data. So if I were to set this to a different threshold, to trigger at 20 instead of 60, this would have triggered the CPU usage warning. So feel free to try that on your own. It's a lot of fun to see that happen when it says, hey, you know, this CPU usage is too high. Captures it in logs, and then it says in the console warning excessive CPU usage was found. So this is my little monitoring script that runs next to GraphWalker. So this GraphWalker example is very straightforward. It's just reading a CSV file that I provided, this in particular. I could also switch it to the CSV file that gets generated at the test setup. Generates it randomly each time, brand new one. I'll show the graph in a second. So I'm reading through that CSV file, which is this one right here. This is the CSV file that I've set up for the workshop, generated by this GraphML file there. I'll show that in a minute. Just want to show this keyword that actually does the mechanism that performs the GraphWalker run. These are the GraphWalker keywords that are also shown in the GraphWalker model. Okay, so let's walk through the GraphWalker. This is the model that generates that CSV file, that GraphWalker path. These edges are actions. This middle orange vertex there, that's a check. We start from the press the 1 button. This is the starting edge. And the GraphWalker jar generates the path based on the edges and vertexes of the graph. That's the GraphWalker example. Now the device, iOS, iPad device looping example is very straightforward. It's just running this in a continuous loop defined from the script that I have here. So go down to the parallel running tests. I define those iterations here. So I'm making sure that it always stops at the around 350 iterations for the monitoring, I should say. For the monitoring will go through 350 iterations. The iOS test iterations goes through 2. This actually takes the longest. iOS generally is it's slower than Android, noticeably slower. And these are the files that are running in parallel. This is how I feed them to PABot. That's it. That's these are the parallel running tests. Let's take a look at the other code too. These are the app examples for Android. These are all the ADB commands that I was feeding from the from earlier. That ps command, ls, dumpsys package command, pmlist. Getting the build version, getting netstat in the console. These are all those ADB shell commands from earlier. Making a phone call from ADB shell, making a text, creating a text message, etc. Also, this is the Android Wikipedia parts of the code. I am calling that via the robot framework tag that says Android app recording screen capture. So the let's take a look at the recording real quick. That was created by that. So that movie was captured here. Might have overwritten it. All the results end up here. Oh. Might have overwritten it from earlier. Okay, so in fact, I think I did. I was running other Android tests earlier from what else to show? What else to show? These are the web examples, the browser examples. This is a Chrome example. Pretty straightforward. So again, the iOS app example. Wikipedia install and run Wikipedia example. It's a Safari example. Very similar to the Chrome example. Just opening up Node Goat, going to the website, filling out the form, checking the dashboard. This is the config file for Charles. You can set up yourself. Again, a license key is very affordable. Just add your license key in here. Now, when you use Charles Proxy, you will need to check your settings here, because it will basically change them automatically. And you won't be able to navigate through your browser unless you uncheck the settings that it automatically changed, and that will revert your settings back and you'll be able to browse normally again. Okay. Alright. Yes, the graph. Let's take a look at the graph real quick. Oh, I think I showed that already. Anyways, that's it. And that's the end of part 2. And this is the end of the workshop. So feel free to reach out to me on LinkedIn or Twitter with any high-level questions you may have. I'm also open to presenting this workshop again, doing it live, preferably not pre-recorded, through your meetup groups. And for deeper dives into the content, I'm also open to live or pre-recorded small-scale online half-day workshops as a service for your team members or organization. So that's it for me. Hope you enjoyed this workshop.